Lesson 9.4, Analyzing the Derivative Graph Level 1. So your job here is now to kind of make your mind think backwards. We're going to be given a graph of f prime, and we have to think about what the regular graph would have looked like. So this is actually part of the answer. Kind of ignore this for now. I just wanted down here to show you what you're really trying to do. So number one says the graph of f prime. The derivative of f is shown below. Determine the values of x, if any, at which the function f has a critical value on the interval -9 to 9. Critical values are anywhere where the derivative equals 0, because what you're really asked to find is where is there a horizontal tangent line. So what I'm going to do here is create what's called a sign chart. You'll use this a lot. Since our interval goes from x values of -9 to 9, I'll put those on there. But then from there, what I want to do is pick out all the zeros. So I have -8, I have -3, 1, and 4, and 8. I made that kind of squished together, sorry. So then what you want to do when it's a derivative graph is figure out, are you having positives or negatives? So right now, from the interval -9 to -8, this interval right here, see how this piece is under the x-axis? That means I have a negative slopes. Then the slope would become 0. Then it switches over into this is all above or in positive y values. So I would say my slopes are positive to -3. Then I'm down below again. So these are all negatives. Then from 1 to 4, I'm still negative. I'm just looking up, is it above or below the x-axis? Then after 4 to 8, these are positives. And then from 8 to 9, I go below the x-axis, so I'm negative. So that's all I'm thinking about is where is it positive or negative? Where is it above or below the x-axis? But what that really means is that my function, my original function, to have a negative slope, it must have been decreasing until -8, increasing till -3, decreasing, and then it didn't change sign, so it must flatten out a little bit, decreasing, increasing, decreasing. And so if you look at this, that's pretty dang close. We don't know what the actual y values were, but we can figure out the behavior of the original graph. And so the critical values then actually end up finding like this is a minimum. And this was a maximum. And right here, so that's not a min or a max, but at least it has a horizontal tangent line. Here's a min, and here's a max. Okay, so what's happening is this original graph, they're going through and saying, okay, when x was -9, what would be the instantaneous slope right here? Some kind of negative, maybe -0.5, I guess -2. And then as it comes to this here minimum, the slope is going to get smaller and smaller until it gets to 0, or actually it's getting, I guess, I gotta think about that with a negative. Yeah, I guess I shouldn't say smaller with a negative, but it's getting less steep. It's getting more gradual until it's going to flatten out here or have a slope of 0. So that's why at -8, it crosses through at 0, because that's the slope of the original graph at -8. Then it starts to get positive slopes. So that's why you see these y values positive. It gets the steepest slope here at -4. So it's getting really steep here before it starts to level back out. And then at -3, it comes back. So see how quickly the slopes get less steep as we go over a hill or valley. And then we're back to a slope of 0. And then the slopes are negative until -1. They're still negative. So that's why we come to -1. They're still negative, but we're starting to round out and get flatter until it's a slope of 0 here at 4. Then we increase. So the slopes are positive. And then we flatten out here at 8. And then we go down or decrease, so that's why that slope is negative. So in long story short, then the critical values are anywhere where we had a min, a max, or some kind of flat or a horizontal tangent line. It's also where it's undefined, but we don't have any of those yet. So x values would be negative 8, negative 3, 1, 4, and 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? Whew. Okay, then go to the next page.